they have, for example, 3 plus x equals 10. Okay? They do not pass the string to the other side.
Okay.
The thing they do, will we have another color? No.
No,
Okay.
sorry.
The thing they do, I'm going to erase this. The thing they do is that they do this little trick. They say here -3 and -3. This has a plus inside. So it's called the uniform property.
Okay.
The uniform property means that this is going to be eliminated by this.
Yeah.
So the x comes here normally, and 10 minus 3 equals to 7.
Okay.
That's
That's the way
the way they solve it.
Okay.
Okay. It doesn't matter if you have a different thing. For example, I don't know. Let's say x square. It's with q, right? Square. Square. That's the way they say. Or the normal way, the usual way you got to say is to the power of.
A la potencia de.
Power.
Esta la vimos.
So you say x to the power of a. A equals to any number you want to use.
As a potential.
So if for example you have this, you have x squared minus 9 equals to 40. You need to solve this.
Yeah.
So you again do the uniform property. So you take 9, you do minus 9 in both sides. So you say x squared minus 9. This is minus, so you do plus 9
Plus.
equals to 40 plus the same 9. So you don't have to, the equation doesn't seem changed. So this is going to go with this, and we have x squared equals to 49. So we know the opposite, how do they call it, opposite operations. So this is a power. The opposite operation of a power, x, is a square root, or just a root.
Root.
If we have this, we have a square root because of the square here.
Okay.
So we, again, uniform property, we took the root here and took the square root here, and we have this goes with this, x equals to 7.
Yeah.
Any doubt until here?
Okay.
Okay, I'll go on with the normal functions. The functions you usually need to know are the linear function. Just a line is composed by an equation that has y equals to mx to m times x plus b, where b is the where the line cuts with the axis y. So axis y, this is the y axis, axis and the x axis. So
B is like.
B is this point where the line crosses with the y axis. This point. M in Spanish, pendiente, is the slope of the function.
Okay.
So this is going to tell if the line goes this slope or this or this. It says the inclination. Let's say the inclination. And this function depends on the variable x. So the x is the one who's going to change, and the y is going to receive the values of the depending to this variable, because this one and this one are constants. For example, you're going to have y equals to 3 times 6 plus 3.
Okay.
Let's say plus 4 because plus 4. So you may have that in this case, this point is gonna be 4. This
Okay.
point of here.
Yeah.
And the slope of the line is gonna be 3.
Sure.
So you're gonna have something like this.
Okay.
It has a high inclination. If it was, for example, I don't know, a half, it will be something like this, because it's the less inclination. In the case of this linear friction.
Oh, okay.
It's according to y.
No, y depends on m, on x, and on the letter b. The only one who changes is the letter x, because according to the values of x, y is gonna take some values. That's the basic one. Can I erase this?
Yeah.
Then we have the next one is the quadratic function. Quadratic function. That you may know for being a thing like this.
Okay. Yes.
The usual equation of this function is going to be a times x squared plus b times x plus a value recorded by c.
Okay. Yeah.
Again, the independent value is the one who's gonna tell the cut with the shape with the axis y.
Okay.
So if c is something like, I don't know, let's say -5, the cut is gonna be like this, -5. It's gonna be something like this.
Okay.
Yeah. For the other side, if you have a positive a plus, this thing is going to open to the upside. But
Okay.
if you have minus a, it's going to open this side.
Oh, okay.
Yeah. And it can be moved from the x-axis dependent of the value of b.
Okay.
According you go doing exercises, you're going to learn
Okay. How it works.
how it moves.
Okay. Yeah.
Comportamiento se me fue.
Behavior.
Behavior, sí. Okay, this one, check. The third one, cubic function. Cubic function. This is going to be, they're like cousins one to the other. We had at the beginning, this is gonna be a times x of 3 plus b times x 2 plus c times x plus d. And the first one we had what was y equals to mx plus b. As you may see, this is going to change the x squared and cubic x.
Oh, okay.
So the thing is that they are called that defines the degree of the polynomial. This is a polynomial of the 1 degree, degree 1. Yeah. Here the x squared is the biggest one, so you have a polynomial of 2nd degree.
Okay.
And this one, so the x is a cubic x, so you have a 3rd degree polynomial.
Oh, okay. Okay.
The basic graphic of this thing is going to be like this, something like that. Again, the independent value is going to tell the change, and these two values are going to tell if it moves in the x-axis or the y-axis.
Oh, okay.
And the value of a is going to tell how does it open. If like this, or it could maybe open. Maybe be open like this,
The opposite.
depending on the positive A or the negative a.
Okay.
It can go on and on and on and on and never end because the degree is never going to have a limit.
Yeah. But
Yeah. Also, there are other very weird functions that we call. Oh, you remember the root we had?
Yeah.
Where there are radical functions.
okay.
So you have something like y equals to root of x,
Okay.
which is going to be something like this. There are many programs, I can give you the names of some of them, many programs that can do these drawings. So they give you the graphic and you learn how does it
Step by
behaves.
step.
Step by step, how does it behave. Because for example I have here y equals to root of x minus 1. I don't need a computer to tell you this is going to be like this. When you do exercises, they go like this. It moves. Why? Because it has a minus and it moved to the positive side. As mathematics. Do mathematics until you learn these kind of things. Which will be a different thing if we have, for example, root of x plus 1. That will be something like this. It's weird as fuck, but you need to know it. You will learn about it as you go training and you go doing some
Exercises.
Exercise.
Some exercises.
Practicing.
yeah. Then we have some weird formulas like this one. X squared plus y squared equals to 1. Do you remember who was Pythagoras?
Kind.
Pythagoras was the guy who told us that if we have this c side and this is this c side, and we have this side, the square of this side equals to the first.
The hypotenuse.
¿Cómo es el nombre de esto? Cateto.
I don't know. Adjacent something.
You need a 90
Let's check it.
degrees.
Check it out. Cateto.
Cateto.
Really?
No.
Maybe.
No, mami. Lado que junto con otro tengo la
Sí, like.
Okay, let's spell it next.
Sí,
I need another one. No. Okay.
Yeah, the sum.
The square of the hypotenuse.
Hypotenuse.
The square of the hypotenuse equals to the sum of the.
Of the two legs.
Sum of the square of the two legs.
Okay.
And you could do anything you want because you can find this side, or this side.
Yeah.
But only in this kind
Angle?
of triangles.
Okay.
Because they have 90 degrees angle.
How do you say despejar in English?
Clear.
Okay, pero in mathematics, despejar, limpiar, aclarar, clarificar.
You
Yeah.
have the equation.
Yes.
So, according to this, with this thing, you can draw a circle. Let's say it's a circle because I suck at drawing. So let's say it's kind of a circle. So it's gonna be on the tape, right?
Yeah.
Sorry. Which radius is gonna be 1? 1 equals to the radius.
Okay.
The normal equation of this will be r squared because r equals to the radius of the circle. So you can do a bigger circle or a smaller circle according to this, and you also can move it.
Okay.
The fun thing is what I told you some time ago about the things when we move this. For example, if we do x minus a squared plus y minus b squared equals to radius squared, you're gonna have something like this. Let's say this is gonna be the center of the circle.
Okay.
So this distance in the axis x is gonna be a. You did x minus a. Why here is x plus a? Because mathematics is like that. When you solve the equations, they do these results.
Okay.
And it moved.
The distance is the radio, right?
Wait, this is the point B.
Mm,
And this time, this space of here is the radius of the circle. So what is it for? When you go through mathematics, you will realize that everything, everything has mathematics. Everything in life. For example, the way they do the football balls,
Yeah.
it has kind of a causing of this equation
Okay.
with the radium and stuff. And for example, the exercises that I do in my university, they ask us, for example, to find the mass of a sphere. Let's say this is a sphere.
Okay.
Let's say this is a sphere. Find the mass of a sphere with an equation like this. So you need to do some weird process called integral that gives you the mass, the I see that.
density?
See that?
Really?
Okay, the mass, the density, and other properties of the ball.
Okay.
Okay?
And the pressure? No. That's another thing.
Yeah, also you can find that. What's the fun thing? When, for example, they told you that you need to do, I don't know, something with this form. In the downside, it's like this thing, like a cone.
Yeah.
And in the upside, it's like a half sphere. Yeah?
Yeah.
So, this is a part of a machine. And you need to know its mass, its density, its electrical charge. You do that with math. You need to describe these forms with math. And you need to do process with those maths, with those formulas that I have here.
Oh, okay.
So, the first month, you're going to ask, why the hell am I learning this? Then you are going to say, this is why I'm studying this thing. Because, well,
This is
numbers.
so awesome.
This is because the world is made of numbers.
The world, nature, everything.
Everything.
Even space.
For example, if you go to an ambiental engineer, I can present you
Environmental
environmental.
engineering.
Okay, sorry, the environmental
It's
engineer.
okay.
I can present you the number E. Why that letter? Because some crazy mathematical said that this number equals to 1 plus 1 divided by n. All that thing to the power of n. And the go you grade that number n, let's say n equals to, I don't know, 1 and as many zeros as I can do before I get bored. Yeah, if you do that, it's going to be something like 2.781, something like that. With that number, you can know how many leaves is going to have a tree, how high this is going to grow, and many things like that. I mean, trees related to numbers, where do you find that?
Is
it's
that
awesome.
magic?
It's awesome. Then, what else can I tell you? Well, in our normal life, the normal life you're going to have, word problems that have to see with limits. Have you seen limits in the school and stuff?
I think so, I can't remember.
You can't remember, doesn't
Really,
matter.
Yeah.
It doesn't matter. You know why? Because you only need them when you're going to derivate. El nombre de la vaina.
Derivate.
Derivative.
Derivative.
Well, let's say they tell you you have, let's say you work in an excavation.
Okay.
Yeah, they are digging for earth and minerals and stuff. So you have a certain amount of, I don't know, this is going to be gold because you're digging for gold.
Okay.
Yeah, and they ask you how many gold are they going in this moment? How many are you grabbing in this moment? Yeah. So for this amount of gold, there's an equation. There's an equation that depends on, I don't know, the radium or the speed of the machine, something like that.
Okay.
When you do something called derivative,
Okay.
maybe you get to see that thing, derivadas.
That's why you're here.
Okay. that tells you the speed that this value is going to change. So you could tell, for example, boss, at this moment we're digging, I don't know, 5 pounds of gold every hour. And the next hour you're digging 7 pounds of gold every hour. And it keeps growing and growing. But in a certain moment you stop growing, so you like the last hour we're digging for 10 pounds of gold every hour. Now we're digging for 9 pounds of gold every hour. That's what the derivatives are for.
Okay.
You can use them. For example, there's an example that I really like. You have this.
Can?
No. Una lámina.
Ah.
Pero no es slice.
I don't remember. Heidi knows. Yes, because he taught in the engineering faculty in Universidad Libre, and all the vocabulary was like that, materials and all that stuff. So he knows.
You have this cardboard sheet, for example.
Oh shit. Yeah.
Una lámina de cartón.
Okay.
Pues si no llega a ver. Okay, you have this cardboard sheet, and they tell you to do a thing like this. Let's say this is a little box. This is a little box. Let's say. So you have to cut a space this here, a space like this. You have to cut a space like this, space like this.
Mm-hmm.
Okay.
And they tell you this equals to x, this equals to x. And all the spaces here equals to x. So the derivatives are useful to know how much can you cut until
Okay.
you get the maximum volume here.
Okay.
Max volume. So you get the max volume and you get the less wasting. The less wasting. So you waste the less, you use as much as you can, and that's why molecules are important in some enterprises. For example, this can happen, I don't know, for a cigarettes empresa.
Manufacturer?
Let's say a cigarette boxes factory. They can use these kind of processes to know the maximums of these prices of these cuts. It's called maximums and minimums, and you're going to learn it when you see again the derivatives.
Okay.
Okay, it's a fun fact that you turn, for example, if you have this function f equals 2, I don't know, x to the power of 3 plus 3x squared plus 5. So the derivative of this function is going to be 3x squared plus 6.
Okay.
You don't remember how to do derivatives, so you have to trust me this time. And the fun thing is that we can turn this on this, or also this on this. Okay, you can do the word backward with something called the integral. Integral that goes through a limit from a to b of any function you want
Okay.
that was derived to the according to x.
Okay.
The meaning of this thing is that if you have a function here, for example this, you give this is x and this is y, you give it a little limits here. It goes from a to b, and you can find this area.
The area. Yes.
Okay.
Okay, what is it for? It is used in this state that you have here is used for statistics.
Okay.
Yeah. So, according to this thing, you can find some probabilities. There is an example that, for example, there is an exercise. Sorry, that, for example, in a movie theater, they say, okay, the minimum time that a customer takes to buy his ticket is 10 minutes because he's waiting in a line and then he has to buy the ticket. And then he goes for some popcorn, but he takes 15 minutes in a medium.
Okay.
So they need to know statistics about how many times does it take since he stands in line until he has bought his popcorns and he goes to the movie. Why? Because
The
when
trailers.
the theaters. Sorry.
I know the trailers. They need to know how long.
How long the trailers? How long do
lasts.
they have to wait to buy the movie, the actual movie?
Okay.
These things got worse. Why? Because we live in a three-dimensional world. It has only 2 dimensions. It's like when you have a square here, but you can also have a cube.
Yeah.
Now it got interesting
Yeah.
because this could be the axis x, this could be the axis y, and I'm going to call this axis z. Okay.
Okay.
The thing according to this thing, I'm going to explain it the best way I can. I have a function here. Let's say it's like this. I have a function here,
Okay.
and I have a function here. This thing is made like a supervise.
Okay.
Yeah, it's made like I don't know. If you have
Like one
a
of the
line
faces?
for here, huh?
Like one of the faces of the.
One of the faces of something. Like for example, a mountain. Let's say with functions you can describe a mountain. Let's say I don't know how to draw a mountain. Okay, I don't know how to describe it. I suck at drawing. It's like a supervise.
Okay.
With a line here and a line here, you do a supervise.
Like a surface.
Like a surface.
Yes.
Sorry, like a surface. So under that surface, there's a space. Yeah, there's a space that we not know, but we could know using these things.
Oh, okay.
But with these things, it got worse because we have 2 limits from A to B and from C to D. What is it used for? To find electrical charges, to find masses, and to find what was the other thing? Electrical masses and density.
Oh, okay.
Yeah.
Yeah. Yeah.
This causes that now we are derivating under an array. We are integrating, sorry, under an array.
Okay.
And the worst one for me is when you got 3 of these guys. Because you have here from W to C. Why is it used for? To find masses, to find, what was the other thing? Oh, centers of mass.
Okay.
What is a center of mass? I have this thing. And I can throw